Hello guys, hello everyone. I hope you're all well. Um, Today I'm going to show you something. I have a student from China named Jimmy. Jimmy asked me to help him with these questions. Math League Contest, 2022, 2023, grades 5 to 6, and he's doing the second round. And I have done the questions and I'm having my classes with him. So I also thought that I could share all of these with you. So I'm going to make a video for each 5 questions. I'm going to just make a different video. There are 37 questions in total here, but part 1 of the second round includes 37 questions. And I'm gonna break them into 5 questions and make a lesson about 5 questions. Because this is the first video, I'm gonna do question 1 to 5 today. Well, these questions are easier than the following questions, so I'm gonna be doing them faster. Okay, so first question, part 1. Let's begin. Okay, so I'm back here. Okay, how many numbers can you write using all 3 2s and no other symbols? For example, one of the numbers is 2 to power of 22. However, 22 is not correct number since is not a correct number. It can only 2 2s. Okay. So we only have 3 2s and we want to make different numbers, right? So basically, of course, the easiest one with 3 2s we could write is 2, 2, and 2, right? 222. Okay, obviously. Okay, so remember, we cannot add symbols. So of course, we cannot write 2 times 2 times 2 because we are using crosses here. Okay, no need for that. So 222 is one number. Okay. The question has already given you one of the answers, 2 to power of 22. And of course, 22 to power of 2. I think everybody can think of these 3. But now the question is very easy. Is there something else we can make with no other symbols? Yes, I think yes. So it's going to be 2 to power of 2 and then to power of 2. Okay. It doesn't matter if you start doing these 2 first. It's going to be 4 to power of 2, 16. Or if we do these 2 first, let me clean them. If we do these 2 first, in this case, this is going to be 2 to power of 4. Again, 16. Okay, so what was the question? The question was how many numbers can you write with 3 2s? Okay, so that's going to be 1, 2, 3, and the last one is 16, like 2 to power of 2, and then the second power. So I would say 4 answers. Okay, guys, remember, I'm not saying that all answers I give here are correct. Well, I'm giving my answer, and I also give my reason. You could just listen to it. If you like it, you could learn from it. If you don't like it, okay. So you could move on. So let's see question 2 here. This is a little more interesting than question 1, probably. Mr. Ladybug meets Miss Ladybug on a petal of flower. Okay. I'm a boy, says the one with red dots. So this one would say, I am a boy. It's claiming that I'm a boy. A boy. Remember, it says red dots, but it's yellow. So the yellow one with red dots says I'm a boy. The one with red dots. Oh. Okay. I'm a girl, says the one with yellow dots. The one with yellow dots says I'm a girl. Okay. So they are both claiming to be, one of them claiming to be a boy, the other one is claiming to be a girl. Okay. And then they both laugh because at least one of them is lying. So maybe one of them is lying, maybe both of them are lying. Let's see which one is possible. Let's see if one of them is lying. Okay, if one of them is lying, for example, this one is lying, so this one would be a girl. And this one is telling the truth, so I'm a girl. But that's not possible because the question says one of them is a boy, one of them is a girl. So that's impossible. The same story. If this one is the liar, so this one would be a boy. The other one says I'm a boy and is telling the truth. So we have two boys, again, impossible. So what is the conclusion? That both of them are lying. So this one is telling a lie. So this one is a girl. This one is actually a boy. Which of the following statement is true? Mr. Ladybug has red dots. Okay, Mr. Ladybug has yellow dots. So because it says Mr., of course, we're looking for a boy. Okay. This one is a boy. Okay. The boy has yellow dots. So we would go with B. B is the right answer. Okay. So that's question 2. Okay, we have 3 more questions for this video. Okay, I'm gonna make a question a little larger for this one. Okay. As shown below, a red closed line is drawn so that it crosses a blue closed line from inside to outside or vice versa exactly 10 times. Is it possible to draw a new red closed line over the same blue line so that it makes only 9 crossing? Okay, so let's just understand the question better. There's just 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, so there are 10, and we're going to call these crossings. Okay, and of course, it's a closed line or it's a loop. Okay, so we want to see if it is possible to make it 9. Okay, so let's see, for example, I'm going to go completely random. How many crossing is this? 1, 2, 3, 4, 5, 6, 7, 8. Now it's 8. If I go here, I close it with 8 loops. It's impossible. 8. If I go inside, 9. And then, ooh, okay, that's like 10. And it's going to be 10 crossings now. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. So what we could do is I would have 3 different assumptions, right? Maybe we could start, the starting point maybe is inside this shape. In one case, we could try this. In another case, we could start from outside. And in the last case, we could start from the line. Okay, we're going to try all of these 3. Okay, if I'm inside, okay, it's going to be, oh, let's just count. I started from inside. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, now I have 10 crossings, so it's not 9. Now, starting from outside, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Guys, remember, if you know the questions, you don't have to listen to the question. You could skip the questions. Okay, and let's just start from over the line. Okay, so maybe that makes it 9. So let's go. Okay, I'm gonna go like, start from here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see now. Let's see if it's 9. This is gonna be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 again. Okay. So again, not quite. Okay. Let's see. What if from the last one? Ooh. Okay. Let me clean this. I'm gonna clean this. What if instead of the last one, okay, instead of coming here to make it 10, okay, I would go from here to here. Now it makes it 9 crossings, right? So that's gonna be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Wow. So is it possible? Well, that's 9 crossings, okay? And then it's a closed loop. Are you gonna write yes? Well, one thing is here it says to have a crossing, we need to go from inside to outside or vice versa. Okay, but this point for this one, well, we're not going from inside to outside. Both of them are inside. So I think this one doesn't count. So this is not going to be one possible answer. So I would say the answer, is it possible to have 9 crossings? Well, I drew it, but I would write no, it's not possible. Okay. So let's do question 4. Okay. John and Pete have 3 pieces of paper. Each of the boys picks up 1 piece, tears it up, and puts all the smaller pieces back. John only tears a piece of paper into 3 smaller pieces, while Pete only turns a piece of paper into smaller pieces. For there to be exactly 100 pieces of paper, at least how many times does John have to pick up the paper? Okay. So first, let's see it here. Imagine we have 1 piece of paper, and then John would make it into 3, okay? John turns it into 3. So it's a piece of paper. John would pick it and turn it into 3 pieces. That's going to be 1 piece. Maybe like this. That's 1 piece. And then this is going to be the second piece. And this is third piece. Okay, this is random. I'm picking just random pieces. Okay, so let's see. John would go from 1 piece to 3. So how many pieces does he add? John creates +2. So because it takes 1, creates 3. That's for John. Okay. For Pete, however, for Pete takes 1 piece of paper, turns it into 5. Okay. So what Pete does is adding 4 new pieces with each tear. Okay. So we have +3 and we have positive, no, sorry. We have +2 and we have +4. Okay. Okay, at the beginning now, reading the question again, John and Pete have 3 pieces of paper. So the starting point is 3. They have 3 pieces. Okay, John would create only add 2. So 3 becomes 5. Okay, again, John does it, it's going to be 7. If Pete does it, it's going to be 11. Okay, so because it's always an odd number, and they could always add even numbers to it, so they can never create an even number, right? So the answer would be E. There will never be exactly 100 pieces of paper, not just 100. So for any even number, the question would be impossible. Can we create 50? No. Okay. So I think these questions are easier. The questions get a little more challenging later. Okay, so we're gonna do the last question, question 5. Let me read the question. We have 3 friends. 3 friends talked about Amy. So, but only one of them knew the truth. Okay, only one. This is a key information. One of them says Amy has invented at least 100 toys. The second one says she has invented fewer than that. And the other one says she has invented at least 1 toy. And one of these persons are correct. If only one of these 3 friends told the truth, which of the following statement is true? Okay, let's see the first piece of information. Amy has invented at least 100 toys. So the number of toys will be bigger or equal to 100. Okay, now let's go check. Amy has invented at least 100 toys. So this is repeating the same thing. So definitely this one is correct. Gary says it agrees. Now, John says she has invented fewer than that. Okay, so no. So it's claiming, this one is claiming it's more than 100. Here it says it's less than 100. There's contradiction. So this one, no. And then Bob says she has invented at least 1 toy. Of course, if he has created 100, so of course he has created 1 at least. So as you could see, 2 are correct and 1 is false. But here it says only one of the friends. But if this is correct, if this is the right answer, we have 2 people who are correct. So A cannot be the answer. So I'm going to clean it. So I'm going to write for this one, I'm going to cross it. It's not the answer. A is not the answer. Okay, let's go B. Amy has invented at least 1 toy, but fewer than 100 toys. So Amy, let's see, can this be correct? At least 1 toy. So T could be 1. But fewer than 100 toys. That's what it says. Now go, let's check. Amy has invented at least 100 toys. Well, this is not correct. because Amy has invented at least 100 toys. But here it says it's going to be fewer than 100 toys. But here it says, this one says T is bigger or equal than 100. So it can't be right. So this is out. She has invented fewer than 100. So here it says T is going to be smaller than 100, which is the same thing as this one. So this would be correct. And she has invented at least one toy, Bob says. Okay, so of course. So here is correct. So as you could see, if B is correct, we'll again have two right answers. So, but we want only one of them to tell the truth. So we only have two options. If C is out, then we'll just have to choose D. Amy has invented zero toy. So no toys. Amy has done nothing. Amy has invented at least 100 toys. No. Here it says T0. Here it says 100, blah, blah, blah. John says, she has invented fewer than 100. So here it says, okay, John says T is smaller than 100. The number of toys. But here, this one says T is 0. Well, 0, as you can see, 0 is smaller than 100. Okay, so I would say this is correct. Okay, that's a true sentence. Okay. And the last one, she has invented at least one toy. Bob said it can't be, right? Because here it says it's 0. Here it says it's 1 or bigger than 1. So two of this pieces of information are wrong, and one of them is correct. That's exactly what the question is looking for. See, if only one of the friends told the truth, which one of the following statement is true? Okay, so we would go with C. C is the right answer. Okay, that's the end of the first video. I'm gonna make more videos covering the next questions. So if you watch this, you have questions about any of other questions, you could ask me. If the explanation was unclear, okay, you could ask me to make the video again. Or if there are other similar tests that you would like to be covered, you'd like me to cover them, okay, leave it in the comments. Okay, we'll see what we could do about it. Okay, that's enough. Okay, see you in the next video.